goal is to simplify numbers in radical form. Here's a few pictures of some radical maneuvers to kind of set the tone for us. Now in math, when we're talking about radicals, we're talking about these kind of numbers here that have the square root symbols you've seen before. Some radicals have an easy-to-use simplified expression. Easy-to-use radicals like this are known as perfect squares. But we don't live in a perfect world, do we? In fact, most radicals don't simplify neatly. Kind of like this one right here, the square root of 50. If I put that in a calculator, I will get a non-perfect number. In fact, it'll be a big mess. It'll be like 7.0107 blah blah blah. Well, here's a better way to represent the square root of 50. In fact, the square root of 50 can be represented as the square root of 25 times the square root of 2. Right? Because 25 times 2 is 50. And what's great about the square root of 25 is that it's a perfect square that turns neatly into the number 5. So then instead of having this big old mess like this right here, the 7.07 blah blah blah, I just get 5 times the square root of 2. Here's a summary of the 3 steps that we'll be doing to simplify radical expressions. Let's try these 3 steps with the square root of 27. First thing we'll do is find the largest perfect square that divides evenly into the radical. Now it can't be bigger than 27, so let's start off with the square root of 25. Does that fit evenly? No. How about the square root of 16? No. But the square root of 9 will fit evenly into 27. In fact, the square root of 9 fits evenly into 27. The square root of 9 times 3 equals 27. The last step is to simplify the square root of 9. Because it's a perfect square, it turns neatly into the number 3. We're now done with this problem. Now you try one. Simplify the square root of 243 using these 3 steps. Oops, actually it is 3 steps, even though it says 1, 3, and then 4. Silly me, I forgot to fix this picture. Oh well. Happy simplifying.